Welcome. In this today's video, we'll be discussing on Way Anova. Previously we have discussed two sample t-test where the dependent variable was a continuous one and independent or the grouping variable had only two categories. For an example, we have discussed English marks for males and females. In this ANOVA or one-way ANOVA, grouping variable or the independent one has more than two categories. Their null hypothesis will be, for an example, three means are equal. And in the case of alternative hypothesis, it elaborates that at least one mean differs. In other words, we'll be checking if that is so, what is different from the other two. For that purpose, when the ANOVA test is significant, we will be conducting subsequent post hoc analysis. However, there are assumptions for ANOVA. Just to brief, they are: first, dependent variable should be a continuous one. For our example, this can be English marks. Second, independent variable should consist of two or more categories. In our example, we will be taking three school types A, B and C. Third, independence of observations. Fourth, there should be no significant outliers. Fifth, dependent variable should be approximately normally distributed for each category of the independent or grouping variable. For that, we will be checking normality. Finally, sixth one, homogeneity of variances. We will be evaluating for Levin's test statistics. With that, we will proceed with today's one-way ANOVA analysis. Here we have three school types and English marks for each student from respective schools. First one, we will be checking the normality. For that, you can use analyze, descriptives, explore, and you can select under dependent list marks, factors, school type, and no need to select statistics. If you wish, you can proceed. Otherwise, under plots, select normality plots with tests, and if you wish, you can select stem and leaf and histogram as well. Thereafter, continue, and you can select only the plots if required as a bare minimum, and OK. Then you can refer in the output test of normality. Here you can see both the case and SW test statistics are not significant, meaning these data are normally distributed for all the three school types, as the figures are above 0.5. Even these plots are indicating the same. And in case if you have requested for descriptives, you will notice mean, trimmed mean and skewness and Curtis's figures, and those are towards normality. So here in this box plot, we can refer the latter stage Next thing, now we have referred for normality. Second, we will be checking for outliers. For that, you have to refer this box plot. Here you see that both of these A and C means are somewhat similar. In this case, mean is little bit lower. However, there are no outliers for all these three school types. Next thing, we will be referring to homogeneity, and for that we will be calling for Levin's test. For that, you have to visit analyze. Compare means one way Anova. Under dependent, select marks. Factor, select school. Then select contrast. Just leave it. And options, you can select homogeneity of variance test and means plot. Press continue and OK. You will be getting the output, and first thing you have to refer is homogeneity of variance, that is to satisfy the assumption of variance, of homogeneity of variance. Here it implies that homogeneity of variance is being satisfied as the significant value is more than 0.05 and this is not significant, so implying homogeneity. So we have satisfied the assumptions, and now we will be referring to ANOVA table and the significance of F statistic. Here you see that F figure is significant, meaning there are differences between these three English mark means of three school categories. So now you have identified there are differences between these three school type for English marks, and now asking in which school type difference exists. So next thing, we'll be conducting, as we have already established ANOVA figure is significant, we'll be proceeding with post hoc test. Select analyze. Compare means one way ANOVA. There you have to select post hoc. You can select any of these, however most of the time researchers select Turkey, otherwise Bonferroni is also okay. Select Turkey and press continue and OK. Now you will be noticing, in addition to ANOVA table, you will be getting post hoc test table. Here you can see significant statistics are given for A and B at the first row at the top, second A and C, and we can see that A and B is significant. A and B is significant, meaning there are differences of means of A and B category schools for English marks, and when you take A and C, this is not significant, meaning their marks are almost the same for A and C schools. Final thing is, now we have calculated A and B, A and C, and final thing is B and C. So when we take B and C, this significant. That also means their mean English marks are different. That is, B and C school grades English marks are different. So in nutshell, we can see most of the time A and C are similar schools when we consider English marks, and B is bit different. So when you go down, you can see means plot. That is what we have requested. So there, of course, we can see this difference. A and C marks are somewhat equal, and B schools English marks, mean average marks, are lower. So that is also indicates the difference between B towards A and B towards C. So now we'll be ending today's discussion, and as a summary we can tell that first we'll be conducting one way ANOVA, and the ANOVA, if the ANOVA statistics is significant only, we'll be proceeding with post hoc. Post hoc analysis indicates where the difference exists. So today's session is over. Thanks for watching.